Alright, this is basic training for circles. Yay, we're almost to the end. Okay, circle, very important field in the shape field of geometry. We're going to examine the relationships. Yeah, those sound effects are in the whole thing. A circle is the distance from a set point. So if I got a point here and I come out, let's say 8 inches, whatever, right there, and I come out 8 inches here, and I come out 8 inches here, 8 inches, 8 inches, 8 inches, 8 inches, 8 inches, all the points that are 8 inches away from the center, then I end up with, when I fill all those points in, I end up with a circle. So that is the definition of a circle. Probably thought you knew what a circle was. Yeah, right. Okay, not just the shape. All right, so that's what we just went over. When you name a circle, you put a little weird, that's called a bird's eye. It's got the little dot in the center symbol for a circle. So this is just called A from the center being point A, circle A. So easy enough. All right. Remember that your diameter, and this is not on the notes just yet, the diameter is the entire length going from one edge of the circle to the other through the center point of the circle. It has to go through the center. Most of the time they'll put a dot, but sometimes if they don't, that's usually the diameter right there. That whole length. And it's always going to be twice the size of the radius. So if I had this was the diameter, then halfway would be the radius, so the radius would be 5 right there. Diameter goes all the way across, radius only goes halfway. So if I got a radius and I want a diameter, I just think, okay, what's the rest of the way? That'll be another 10, and it would be 20 for the whole diameter. Think about it. If it's going to have a radius of 10, then anywhere you draw the radius is going to be 10 every single time. 10, 10, 10, 10. All right, any radius on there. All right, so which of the following is a radius? PQ, yes, no, yes. All right. QR, yes. QS, yes. From the center out to the edge. Okay, all of the above would be the answer. All right, what about the next one? If PQ is 3, how long is PR? The whole thing, of course, would be 6. That would be the diameter. Cool. All right, now for a challenge. See, we're in basic training. Yeah. If we've got one radius of 32, the other one's 20, and that little piece in the middle is 5, can you find these missing pieces? Think about it. 32 for one radius. So what would this other radius be? 32. They have to match. So how do I find this missing piece? Guess what's back again? Segment addition postulate. Little piece plus little piece makes the big. Subtract it, you get 27. Same thing here. 20 for the radius, 20 for radius. I need another 15. Ain't that great? Okay, good job. All right. We start talking about the degrees of your circle. Of course, it's going to be split up, but if we have all the diameters and they get cut through, like on pizza, when they take that big blade and they slice it, how many diameters did it take to cut this pizza this way? How many straight lines is it? 1, 2, 3, 4. 4 diameters cut it into 8 equal pieces. Okay? Because each one is going to the center, so it does. Alright. Alright, so here's your vocabulary. Some more vocabulary. There's a lot of vocabulary in this chapter. A chord of a circle goes from the edge of the circle to another edge of the circle. That is a chord. It does not go outside. It does not stop up in the middle somewhere. It goes from an edge of the circle to another edge of the circle. It's like a little bar that's attached each end on the edge of the circle. Notice there's one going through the center. So if I did that whole thing, that would be a diameter. So the diameter is a chord. But what do you think is more important? Calling it a diameter or calling it a chord? Calling it a diameter, of course. That's more important. That's a special chord. The diameter. Every diameter is a chord, but not every chord is a diameter. That's a chord, that's a chord, that's a chord, but there's only one diameter right there. So, all right, so what is PR? Is it a diameter? Yes. Is it a radius? No. Is it a chord? Yes. It's a diameter and a chord. Which is a chord but not a diameter? PR? No, that's a diameter. QS? That's just a radius. PT? That's it. Okay? Just a chord, not QS. So next we're looking at a secant. And a secant of a circle goes through the circle, inside and outside of the circle. It can be just a segment. See, this doesn't have arrows. It's got an inside part and an outside part. All right, or it can be a whole line with the arrows. Keep on going either way. Or it could be just a ray. Now notice how this one does. From X through Y. Here's X down here, this point. Here's Y, this point. It starts on the edge and it keeps on going. It can do that. Is it inside the circle? Yes. Hitting at the 2 points? Yeah. Is it going outside the circle? Yes. So that is a secant. Secant is also used in trigonometry as one of your sine, cosine, tangent, secant, cosecant, cotangent, one of those others. But this is a different kind of secant. I use the same exact word. I know, it drives me crazy too. All right, but this is the secant of a circle, and it goes inside and outside. If I just said AB like this, is that the secant? That's just a straight bar on top. A to B, the segment, right, is just a chord. Look at it. It starts on the edge, it stops on the edge. If I put it as a straight bar and I'm looking at that piece, then that's it. But if I say line AB, then it's going to keep on going and keep on going, and that would be a secant. Okay? Otherwise, it's just a chord. Like that is a chord. All right? Questions? Yeah. All right, we'll talk about it next time. All right, so then there's a tangent. Yep. Trigonometry again. Why they couldn't come up with new names, I don't know. But a tangent is a line that does not go inside of the circle at all, but it does touch it at one exact point. So it's just like a stick that's rested on top of the ball right there. And it can be just a ray, okay? That's a ray right there. And it doesn't go inside, but it is going to touch at that one point on the circle. Now, tangents are very useful for a lot of things, especially Galileo used them to figure out the distance between planets and the sun and all that, and we'll get into a little bit of that in a minute, because of trigonometry and because look what the radius does. Whenever you have a radius going to a tangent, point where it's hitting that point of tangency, it always forms a right angle. So that opens you up to, hey, Pythagorean theorem, trigonometry, special right triangles, all that good stuff. So that's how they used it. All right, concentric circles are one circle inside of another. So if this was a circle A, they would both technically be called circle A, but it's more about they have a lot of the same features. So they have the same center point, just like a target would. All right, then there's the word circumscribed. All right, circumscribed, not circumcised, that's something totally different. Circumscribed is when the object is drawn on the outside of another object. The object must be touching the other on every side. So the triangle is circumscribed. Then there's inscribed, and you would say that it's on the inside. So circumscribed's on the outside, inscribed's on the inside. The circle is inscribed to the triangle, inscribed in the triangle. And then the triangle is circumscribed about the circle. The inside's on the inside, inscribed is inside. Easy enough. Alright, so, alright, what's that one? The circle would be circumscribed, and the pentagon would be inscribed. Alright, so then you've got some obvious things like the interior. The blue part right here is the inside points that were on the interior of the circle. So the blue is the interior of the circle. Of course, the blue here is the exterior of the circle. It's outside the circle. But if they say on the circle, that means on the rim. That doesn't mean on the inside. On the circle would be right on the rim, right there on the circumference area here, outside part. All right, one more of these. Let's do it with a little bit of algebra. If AB is 5x, then what is BD going to measure? B to D, just in algebra terms, nothing tricky. All right, that's a radius, so that's a radius, so it'll be 5x. Easy enough. All right, what about AD? If that's 5x and BD is 5x, what is AD? The whole thing, 10x. All right, and then if CF is 20, where's CF? That's the whole thing, 20x. Okay, with algebra. What is EF? Easy, that's a radius, so we have 10x.